Today we'll learn how to multiply a binomial with a polynomial expression. The same with a monomial, we want to distribute each term of the first expression into each term of the second expression. It does not matter how many terms are in the first one or the second one. Every term is going to end up multiplying to one another. Now, just a recap on how to distribute. Say that we have a 3 on the outside of the parentheses. This would be distributed to the x, the first term, to give us 3x, and to the second term, 3, to give us a positive 9. When we distribute, we're simply stating that we are multiplying a term into every portion of a parentheses, another expression. Now there's a couple ways to look at this. One way is the box method. This is the easiest visual one. There is some prep work where you have to create the box. But when you do this, you can use rows and columns for your values. Our first two columns are x and 3, labeled for each term that we have. And then our rows are x and 7 for our second binomial. Now, at any point when a row and a column meet, we will multiply those values together. For instance, looking at our first column, we have x times x. Following our rule, this gives us x squared. And then moving down the line, down the column, we would still have x, and this time we're multiplying by the 7. Now we would shift over to the next column and repeat the same process. With the first row, it's 3 times x, which gives me 3x. Moving down into the next row, we have 3 times 7, which gives us a value of 21. So if we were to simplify this, we have an x squared we have two sections that have an x, so we would combine those to give us a positive 10x. And then in our last box, we have a positive 21. Now the main way that I'm going to be teaching today follows along with all of our other lessons and the distribution property. Oh, tongue twister there for me for some reason. Now originally, if we look back at the top, we took one value and we distributed it throughout everything. But this time we are going to take both of these values and distribute each of them. Now I'm going to try color coordinating this a little bit. With our first term, I can multiply x to the x, which gives me x squared. And x to the positive 7, which would give me a positive 7x. Now that I finished that, I can move over to the next term, my 3, and distribute that as well. This time I'm writing the line underneath just to keep it a little bit more organized. We have 3 times x, which is a positive 3x. So we continue writing our expression. And then our last piece, multiplying our 3 to our positive 7 to finish the distribution. Now if you look, these are the same terms that are in our visual box method. They do the same exact thing. It's all a matter of which one you choose to use as your distribution, your first expression. And it comes out the same way as well. We have x squared by itself, We have 7x and 3x, which is a positive 10x. And we still have the plus 21 at the very end. Those are different ways to represent, I was about to say show. There's different ways to represent and show our work when we do double distribution. So you can pick and choose which one you like the most. For the purpose of how our lessons are set up, our videos are set up, I'm going to continue with the double distribution. But at any point on your own, you can follow along using the box method. So let's go through some examples. If we look at the we do, our first expression, what we are going to distribute first is the 2x. So I would take the 2x and multiply it to x, which would give me 2x squared. And then to finish it off, we multiply the 2x to the negative 6. This gives us a negative 12x. Now, as we see, our first term has been distributed to each of the other terms. We can move on to the next term, our negative 3. Now when I distribute this, I have negative 3 times x, which is negative 3x. Then I have my negative 3 times my negative 6, which will leave a positive 18. Now, if you noticed, our middle section again is like terms. With the double distribution and the way most problems are set up, in the organized fashion, you should end up with your like terms being in the middle. This is not always the case, but most of the time, this is the way it works out. So, the ends, there's nothing to combine them with, so we can just rewrite. We can combine the negative 12x and the negative 3x to get a negative 15x. And then our other end with a positive 18. Nothing to combine with it, so we can just write it down. Now, even if we extend it, we have more than 2 terms. It follows the same steps. We take one expression's term, first term, and we distribute it to each of the terms. Multiplying the first terms gives us 8y to the power of 3, following our laws of exponents. Multiplying our first term with the second term gives us a negative 12y squared. And then the last term, we have the 4y times negative 8, which gives us our negative 32y. Now when we finish all this, actually I want to move this down some. If I can click on it correctly. There we go. So I moved it down some so I can show my writing. I'm going to take my second term, the negative 3, and do the same process. Distribute to the first term, which gives me negative 6y squared. to the next term. So negative 3 times negative 3y gives me a negative 9y. And then our final term, negative 3 times negative 9, or negative 8, gives me a positive 24. So now there's quite a bit. This is where our little designs, our boxing of like terms helps out. I look through here, I see I have a y to the power of 3, and it is the only one. So I move to the next power. I have y to the power of 2. This shows up twice in all the expressions. Then I can move down to the next power, which is just y. And then our very last term, without the y, the constant, has nothing to combine it with. So now we kind of have this mixed pattern of variables in like terms. So we need to be careful whenever we are checking each one of these to see which ones we are combining. The 8y cubed stays 8y cubed. There's nothing to combine with it. My y squared shows a negative 12y squared and negative 6y squared. This will give me a negative 18y squared. Next would be our y's. The negative 32 and negative 9 becomes a negative 41 y. Do not forget which variable term you are referring to. And then last is our positive 24. So if I look, I should have one of each power of the variable and then a constant at the end, showing that they are all non-like terms, and I have finally reached my answer.